Hi, Joyce.
They started working, let's see, what, like 20 minutes? They've been working on numbers 3 and 4 using, hopefully, the limit comparison test, because if you tried homework, direct comparison's not much fun. Limit comparison's a little bit better. One thing that we do have to quickly add an amendment, an addendum? How do you say that for particular legal documents? No. An addendum, I think. Anyway, in the limit comparison test, it is important to realize that you are choosing comparing to b sub k. You are choosing b sub k. So that is the one that you choose. That is the one that goes in the bottom of the limit. So your series that you are given is always on top over the one that you're trying to compare to. So I guess it was kind of in there. It was a little bit hidden, and I definitely did not pull that out yesterday, so I apologize for that. So the one that you were comparing to needs to be in the bottom. We can't just willy-nilly flip it. Now, back on number 3, they worked, they sweated, they discussed, they argued just a bit. They figured out that they needed to compare 2, 1 over n. So what happened, kiddos, as you went ahead and took the limit, as n goes to infinity, of our series over the 1 over n? Oh yeah, we can. Which diverges
Fancy me.
P series n? No, P. P equals 1.
Yeah.
Which is, we'll just stop there. Yeah. Limit as n goes to infinity of our series, which was 1 plus n ln of n all over n squared plus 5 times the reciprocal.
Just the limit ends up being
N over 1. Ends up being ultimately, what?
1.
No.
But if you get n plus n squared ln over n squared plus 5, and then when you think about it, the top comes, because you can cancel out the n squareds, hypothetically speaking.
1.
And then,
If you think degree tests, comparing the 2 degrees, you can see that the top degree is actually stronger, which is what George is saying. Because ln of n times n, ln of n goes to infinity times n squared. It's going to be not a lot stronger, but a little bit stronger. And Joyce, if you want, Sam actually worked it out on the front board using L'Hopital's?
No, just
Degree test. Right, dividing everything by n squared
Yeah.
and simplifying. So ultimately he was able to show that the limit is in fact infinity. Now we can say by the limit comparison test. Since L is equal to what?
infinity.
And the comparison series. Can I say comparison series? That makes sense, right?
Yeah.
Series diverges. Ours diverges as well. We could have written them over and over again, but that's alright. Okay, now on the second one. Does well fit? It kind of does. Anyway. Number next one, ln of n over n to the 3 over 2. What do you guys end up comparing to?
1 over cubed root n.
Which? What does that do?
It diverges by the P series test. Probably got a test there in that case.
P series, P is equal to 1/3, which is less than 1, right? Wait, less than or equal to?
yes.
Yes. Then what do you guys get for your limit?
Infinity.
She means like I just said.
Ln over n over n to the 3 halves times cube root n.
And Joy says, you notice we're just multiplying by the reciprocal to save time,
Wait,
save effort.
did I mess up? I did.
cube root?
Because I messed up. And when I multiplied it into the limit, I did 3
I feel like we've done square root.
Didn't work.
That's
Wait a minute.
Well,
How about
yeah, it's still.
The-
I did my math wrong to begin with, but even after I fixed it, it didn't work.
Yes. It would be 0 in this case. Oops.
Wait, who wins? ln n or n?
No, because the cube, it cancels. It's going to be
If you divide, you subtract, so it'd be 1/3 minus 3/2. If you want to use Sam's way,
2/6 minus.
you would do 1 over. Oh wait, we're just multiplying. We're not even adding, right?
Yeah.
Okay, so that would end up equaling
Ooh. That's wrong.
when it, as n goes to infinity. 1/3 minus 3/2 would be
2/6 minus.
2/6 minus 9/6, which would be ln of n. 2/6 minus 9/6, that'd be negative 7/6.
Mhm.
So that'd be 7/6. Who wins? Who
Bottom.
knows? So then the limit is 0, and we have a divergent.
Yeah, it would work.
Does that work?
Does it?
No,
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 I
so
think
zero is
convergent.
convergent.
Ah, schmuck.
Stink-a-dink. So we haven't figured this one out
Try
yet.
number like 17.
Oh my gosh.
What
Bad
happened
math
with
really
1/2?
just
Was it 0 or was it infinity?
0.
Okay, if 1/2 was 0, we probably don't want to compare to a smaller power of n.
So then just do n.
That
to
makes
the-
sense?
Oh my god, that's so
We do
dumb.
1
n
over
to
n
the-
didn't work either, though.
Was that 0?
1 over n, it would go. I think it would go. It would be root ln n over. It would be ln n over root n, and then what would be stronger? Bottom, right? Was stronger ln n or root n? I didn't go too far. I think it's root n.
We do 1 over n and then 1 over 2 root n. It equals a constant. That's good, right? Let's do that.
It does.
P equals 1. I was doing L'Hopital's in my head real fast. I think so.
What? No.
You were saying root n, right?
Yeah, because when you plug it in, you're gonna get ln n times.
Oh, no. We're doing 1 over n. That's true. And then when we do 1 over n, we get n over 1. And then we end up with, I see. Oh, my divergence got cut off. We get ln of n over root n.
And then who wins? Bottom, right?
And then we can take L'Hopital's, right? So you get 1 over n. Not 1 over 2. 1 over n all over 1
2
over
root n.
2 root n.
And you're gonna flip it, and you're gonna
Oh,
get
that's going to be 0.
yeah.
Bottom wins.
So we, like you said, I think we should do something greater than 3/2. So let's just do 4, I guess. That's
Maybe a while.
But that converges.
Hey, what's something in between n and 3, n to the 3/2? You guys can do this. How about n to the 5/4? Does that make sense? You tried n, and here's what I'm trying to strategize. If you tried 1 over n and it was 0, don't go to the smaller n because it's just going to be 0, 0, 0, 0, 0.
Should we just
0.
try?
So a greater power of n to the 3/2 doesn't work, that's infinity. So try n to the, I would say 5/4. 1 over 4.
N to the 3/2? No, but that conversion. That might hurt.
So to change this, right, because n to the 5/4 is going to converge. Which is kind of, might give us a lesson that maybe we should try the limit before writing all this stuff. But,
The limit equals 0.
which is a good thing, because we have a conversion.
Are we talking about n term plus? Is that what you mean?
P is equal to 5/4, greater than 1. N term, oh, no, I was saying like you can try the limit before writing all the justification, you know what I mean?
Yes.
Because we had to write the justification a few times. So we'd have n to the 5/4.
No, wait to see.
You get 6, and then subtract. You get 1/4, right? N to the 1/4. Or is it negative?
Because we can just double, right? So 5/4 minus 6/4, so we'd have ln of n over n to the 1/4.
And then
Bottom still wins.
If we were to do it, we would have 1 over n. And 1/4 n to the 3/4.
Negative 3/4.
If we flip that, that would end up equaling 3/4 is greater than
No. No,
And
it's
you
not.
just write it this way. So 4 n to the 3/4 all over n. Bottom wins 0, true?
Mm.
Aha! So then we can say by comparison test or by limit comparison.
Can we just say that n to the 1/4 is stronger than ln of n? Degree test.
As long as you're right every time. No, I don't mean that facetiously. I mean like you were right, but that's something that if you were just starting this, how would you necessarily know? You know what I mean?
Yeah.
So, and some things that we logically think are right are not. Like 1 over n diverges, that's weird, but or the series I should say. No.
You're joking.
No.
Ah!
Well, good news, guys. Ready?
Oh, the logic.
If we don't get back in time, look.
Yeah.
We can submit homework. So we did all right. And we figured out.
Oh, there.
Someone want to go peek and see if people are actually going. I feel like it's a prank again.
But shouldn't we still go on?
Maybe. All right, we're going to the 30-yard line.
Can we bring our homework side?
Yeah, bring your homework. You can work on. Nice, go team.
What? Yeah,
Can you bring
I'm
homework?
lining up at the doors.
All right. Wait.
Hey.
Please.
The fire alarm is a false alarm. The fire alarm is a false alarm. No need to react. Fire alarm is false alarm.
Oh.
Please remain in class. Thank you.
Thank you, Mr. Rogers.
Okay. L equals 0.
That was so, like, the most random.
The last one or this one?
No, this one.
Yeah, I know.
No, I'm talking about the problem.
Oh.
The 1 over 5 into the 5/4, it's like, who would think of that?
Actually, this is kind of common to happen on limit comparison, like as far as calculus classes and homework.
Oh my gosh.
But you guys, you recognized, right? N and then n to the 1/2 and n to the 1/3. You guys were just going down like a spiral. You were going down a rabbit hole, and it wasn't going to work. So then we had to go the other way. The n to the 3/2 is too big, so we had to go in between. Since L equals 0 and comparison series converges. All right, you guys want to start looking at the next one? I think we have this one, right?
No.
No, this one, like this current one.
Oh, yeah.
Ours converges as well. Question, just to remind us of where we've been, number 1, where we're going, number 2. Why not nth term on either of these?
We know nothing.
We know nothing. Why not geoseries?
Not geoseries.
That's funny. Why not p-series?
Not P-series.
That's funny. Why not integral test?
I don't want to integrate that.
Exactly.
I think we could have integrated 4 faster than we could have done.
Oh yeah, definitely.
Maybe with integration by parts.
Yeah.
Not
That's
all
true.
like that.
So we could have done that one, but the top one,
Yeah.
not feeling
Oh,
the NL and the N. But yeah, number 4 probably. Okay, number 5. Why not integrate this one?
Number 1, we can do integration by parts too.
Yeah.
Anyway, this one, we can't.
Well, this one could be a trig sub one.
Because you have the N to the N up top.
Oh, sorry. Arctangent. You can make U something funny.
Yeah, but you have an N to the N up top.
No.
Good idea though if we just had the bottom. I would totally say arctan, let's go. Although it's a cube. Never mind, don't do that.
For this, can we make it simple and do like 1 over n cubed, or should we do something with like?
I wouldn't do 1 over N cubed because you have an N up top. But 1 over N squared might be a good
But
option.
if we do
What is
over
the
n
N
cubed,
cubed? Do anything.
if we do 1 over n cubed, we can flip it n to the 4th powers greater infinity, and then that diverges.
Yeah, but 1 over N cubed converges. How about 1 over N squared? Because you have N cubed over N cubed, infinity converges. That's not a good idea. You guys see how your brains are starting to be like, I don't want to do the work if it doesn't work?
Yeah.
Good. That means you're learning the test.
We could do
How about
Let's do
1?
1/2.
1 over n to the 4th. Because it would be no, it'd be convergent divergent.
N to the 4th would be convergent again.
Yeah.
You could try
Oh,
1 over N.
Root n.
Root n.
Because that'll give you 3 halves,
Make it 0.
and never mind. I thought it was 3 and a half.
Oh,
Wait, what about
yeah.
just 1 over N?
No, that
That's n
diverges.
squared.
And it'd be n squared, and then it'd be 0 and diverges. So 0 has to
Wouldn't be
converge.
0.
Yeah, but
I'm gonna try 1 over n.
Hey, good idea.
why wouldn't it be 0?
Cause you have 2 to the n chilling, bud. 2 to the n's pretty stinking strong.
Yeah, that's what I was thinking, like, can we do that with all of them? But no, doesn't matter.
Wait, what?
Well, because we had convergent and so infinite and convergent.
Oh, we need divergent. Okay, I see what you're
So
saying.
1 over
Yeah,
n
that
is
makes sense.
divergent.
Yeah, that makes sense.
Yeah. Try it, bud. Try out the limit. Maybe a little bit too much mental math. We did just do a lot, if you guys think about it. It's pretty impressive.
I was trying it, and I mixed them up. A lot.
Oh, because the 2 over n adds to the n
2 to
squared.
the n.
Sorry, yeah, 2 over n, 2 to the n,
Is there as well.
and that makes it n squared stronger.
Show it.
Okay.
It's on a test, you have to show it, so it's practice.
You can say equals infinity, right?
Yeah.
So then,
Double check me, but I think my mental math is
that
right, right?
works, yeah.
So, as you guys noticed, we were doing 1 over n squared, 1 over n cubed. We were doing convergence and getting infinite limits. Well, let's go try a divergent and see if it's still an infinite limit, then life is good. Alright, strategies.
Yeah. You wouldn't do L'Hopital's in this, would you? You would just be like, yeah, I can tell it a divergence because of the 2n. 2 to the n. That's gonna be a nasty L'Hopital's.
Yeah. You could do what Sam was doing. You could divide everything by 1 over n cubed. This is like the algebraic way of doing degree tests. And then you would have the limit as n goes to infinity. L'Hopital's is ultimately only nice when you have a derivative that's easy. If you have a nasty derivative, L'Hopital's isn't really that beneficial. What does this allow me to do? As n goes to infinity, this just goes to 0. So I end up with four times 2 to the n over n, and at that point we can obviously say, yeah, that limit's going to be infinity. So if you do want a way of showing it, that would be much shorter than L'Hopital's, because yeah, that derivative of the top product rule, not feeling it. We can say by limit comparison. It's like how my limit is progressively getting much thinner. Since L equals infinity and comparison series. Diverges. Ours diverges as well. So I think you guys have pretty much figured out the pros and cons of each of these. Direct comparison is a pain to figure out. A truly bigger or a truly smaller, we're probably only going to use it if an AP question basically tailors or forces us to. Otherwise, limit comparison is almost always preferable, but it can get really frustrating if you don't already have some techniques in place.
Yeah.
So, just because I have this from Melissa and Layla's year, I have a random homework question that they were like, yeah, we don't like it.
Oh wait, on the homework, we're not supposed to do 9-1, right?
Yeah. We don't have that one.
Okay, just making
Yeah.
sure. I thought you may have put like a link or something.
Oh, no. Because 9-1, our 9-1 basically matched their 9-1, hence why I put it on the 9-1 and 9-3 quiz, but I didn't make you guys do another 9-1 homework because your original was sufficient. And it was just limits of sequences, like getting you ready for the nth term test, so same thing.
Okay, is that n plus 1 or is it n? No.
But true, yes. Use direct comparison.
What?
This might have been the one you didn't like.
I think we actually have one of these already.
I didn't like ln of n over n minus 1 or something like that.
What are the terms of this guy?
No, I didn't
It was
like.
2 to the n.
Oh yeah, yeah. ln of n over n plus 1.
3 over 4.
Oh really?
That was the one.
I think I did that one.
And 1 over 2 to n. 2n.
Direct comparison. Somebody bigger, smaller.
Okay.
Ln of n over n.
This is what I was talking about earlier that you guys could approximate, because don't you know ln of n, a couple of things about it. Number one, ln of 1 is equal to what?
0,
0. What's ln of e?
1.
I used my calculator for this one to find out which one's bigger or smaller.
I know, but Gerardo, the whole point of talking about it is to show you how you don't have to. So ln of e is 1. ln of 2.78, no, it's 2.71828, et cetera, et cetera, et cetera. So if ln of e is equal to 1, ln of 2.71828, then what's ln of 2? Something a little bit less than 1. But what's ln of 3?
A little more.
Something a little bit more than 1. So couldn't we theoretically just split this little series up and say, let's forget him for a bit. And let's just do ln of 2 all over 3 plus the series from n equals 3 to infinity of ln of n over n plus 1. Why is that beneficial? Because now I can say, hey, 1 is below all these guys. Wait, smaller, what am I trying to prove if it's smaller? Because I'm thinking 1 over would be less than. So we could compare to,
Wait, isn't ln of 4 like more than 1?
yeah, so I'm using 1 over and saying it's going to be smaller, but 1 over who?
N.
N plus 1, that's what I did.
So that'd be 1 over 3 instead of 1 over 4 and 1 over, wait a minute, oh, is that smaller or bigger?
No, it's smaller.
That's smaller.
Because the top one's gonna get, you're gonna have ln of 3 over, that's like 1/4.
1 is smaller
Oh,
than ln
no.
of 3.
It's gonna be a little more than 1/4.
3 is smaller than ln of 4.
It's not always gonna be small.
So
Oh, n minus 1.
it'd be 1 over 3, 1 over 4. And minus 1, we can do that. Oh, but then we don't know who he is.
N plus 1.
No, that'll be bigger. It'll be smaller. Right?
No.
Oh, that will make it smaller, you're right.
Yeah, because then 1 will be less than, right? And we could say that this compare, can we do this?
I don't really know how to do direct comparison.
Just do your
1 over n would be bigger.
Would they give us one this hard for a direct comparison test?
I don't know, we're just trying to do the problem again,
I
but
think she keeps telling us that these problems, you can use multiple tests to it, and they don't really have a specific test that you have to use. And you just have to
it's more you have to be able to do it quickly and
whichever
efficiently.
test you can use quickest if it works.
1 over n squared would be smaller, but that's convergent, that's not helpful.
Remember when we thought the integral test was hard?
Yeah.
1 over n to the 1/2 would be bigger, that diverges. Let's forget right now that we're having to worry about all of this up here. And let's instead take just a second and think about, but wait a minute, how would we approach this guy down here if we need to figure him out? Why am I going to say which diverges? Can't technically use p-series. Why am I going to say integral test?
That's.
Why can't we use PCs? Oh,
Because it has a plus 1. 3 to infinity. Why am I able to say equals infinity? What am I doing in my head?
Ln.
It's going to be ln of x plus 1, and as you go to infinity, that's going to be infinity. So I can say by integral test, see, we're getting better and faster. So we can say which diverges. If it's smaller, diverges, ours diverges as well, right? Bye.
Yeah, yeah.
Time, Steve.
Bye guys, I'm going to finish writing this. It's nice to read out for one and then I'll see you guys later. Homework due tomorrow. Go over questions. Yeah,
I just finished.
good job.
But
Yeah.
I feel like I forgot everything that you showed us. If I did it wrong, I'm gonna be so mad.
Okay, now try to keep go past.